Welcome to day 3 of May Leetcode challenge. Today we have question number 581, shorted unsorted continuous subarray. In this question they have given us the integer subarray as an input and we need to find one continuous subarray. That is, if we only sort this subarray in ascending order, then the whole array will be sorted in ascending order and we have to return the length of that subarray. So let's see example 1. In example 1 we have the integer array 2, 6, 4, 8, 10, 9 and 15. So this whole array can be sorted if we just sort this subarray, that is 6, 4, 8, 10 and 9. So the length of this subarray is 5 and that is what we have to return as an output. In example 2, they have given us the array that is 1, 2, 3 and 4 that is already sorted, so our input is 0. In example 3, we have an array which has only single element. So the array with only one element in it is always sorted. So in this question more clearly by this example, here I have taken an input array that is 3, 7, 5, 9, 11, 10, 17 and 20. This input array is of length 8. So if we need to sort this input array, we can just see this 3 is already sorted, 17 and 20 are already at its place. If we just sort this box, that is 7, 5, 9, 11 and 10, our whole array will become sorted and the sorted array will look like this. So the first approach is, what if we make the copy of this input array and then sort it, and so after sorting the array will somewhat look like this, or the exactly will look like this. And then if we have to find the length of that subarray that should exactly be sorted, so for that we can make two pointers, start and end. So from the starting, what we will do, our start pointer will point at index 0 and will move from left to right, and we'll see in both the array, that is from the input array and the sorted array, if there is any mismatch it will break. And exactly we will do from the opposite direction, that is from right to left direction. If we found any mismatch, our end pointer or our loop will break and our end pointer will point that mismatch index. So if we'll just first see for the start pointer, a start pointer is now at an index 0 of both the sorted array and the input array. So first we will compare. The input array index 0 is equals to sorted array index 0. Yes, 3 and 3 both are equal. Then it will move to, then start pointer will move to index 1. So in input array it's pointing to index 1. Same in sorted array also it's pointing to index 1. So in input array the number which is there present at the index 1 is 7. And in sorted array the number which is present at index 1 is 5. So 7 and 5 are not equal. So our start pointer will, so our loop will break and our start pointer will be pointing the index 1. And this is we have done from left to right. And now we will see from right to left. Let me change the pen so that we can see this. So now we are moving from right to left. And pointer is again pointing on the last index of both the array, that is 7. And in the input array the last index is 20. Last index has the number 20, and in the sorted array also last index has the number 20. So our pointer will move to number 17, to the index 6. And then again both the element have the same number at index 6, that is 17 and 17. So again our pointer will decrease and it will move to the next index, that is 5. And on the index 5 the input array have the element 10 and the sorted array have index 11. So this is a mismatch. So in the mismatch condition our loop will break and our AND index will be at index 5. So what will be our output? Our output will be the AND index, that is 5, minus the starting index, that is pointing at index 1, plus 1. Now why is this plus 1? We already know that in Java our array starts with index 0. So that's why we are just adding 1. So the output is 5. And that is, we can see it from here also, like 7, 5, 9, 11, 10. These are the 5 element. If we just sort this sub array of length 5, our whole array will be sorted. So that is what the answer. But the time complexity of using this approach is too much. Like first we are just making the copy and then we are just sorting it. So it has the time complexity of n log n, and it has the space complexity of n. Now the question arises, like, can we have a optimal solution or more better solution than this approach? Of doing this is, if we create two variable min and max and we initialized min with the integer dot maximum value, it will find the decreasing value basically by iterating from left to right in an array. And max we will initialized with integer dot min value, it will find the increasing value and it will iterate from right to left in an array. So let's see how it works. So currently our min is on index 1. We will check is the array element present at index I is less than array 0, like array I minus 1. We will check this condition. Is 7 less than 3? No, 7 is not less than 3, so no need to update. We didn't found any decreasing value, so no need to update the min. So we will move to our next index. Now this pointer moves to 5. Is 5 less than 7? Yes, 5 is less than 7, so we got a new min, that is 5. Then again we move to our next index. Is 9 less than 5? No, 9 is not less than 5, so no need to update the min. Then again we will move to our next index, that is 4. Is 11 less than 9? 11 is not less than 9, no need to update the min value. Then we move to index 5. Then again we will see, is 10 less than 11? Yes, 10 is less than 11, but the value we already have in min is not less than 10, so our min will not be updated. Then we will move to a next index, that is 6. Is 17 less than 10? No, 17 is not less than 10, no need to update min. Then we will move to our last index, that is 7. Is 20 less than 17? No, 20 is not less than 17, no need to update our min, so our min will become 5. As we already know that the length of our array is 8, so we will start iterating from the index 6 and we will check, is the value presented index 7 greater than the value presented index 6? If yes, then it, of course, 17 and 20 is in increasing order, we will not change the maximum. So we will move to the next index, that is 5, and then again we will check, is 10 and 17 in increasing order, that is 17 greater than 10? Yes. Then we will move to the next index, and then is 10, is 11 less than 10? 11 is not less than 10, so we got a new maximum, that is 11. Correct, because 11, 10, 17 and 20, these are not in increasing order, whereas 10, 17 and 20 is in increasing order. And now we will again iterate further. Is 9 less than 11? Yes, 9 is less than 11. Is 5 is less than 9? Yeah, 5 is less than 9. Is 7 less than 5? No, 7 is not less than 5, so 7 will become the maximum, but the existing maximum is 11, so 7 is not greater than 11, so 11 will only be our maximum, it will not change. Then again we will iterate. Is 3 less than 7? Yes, 3 is less than 7, and our iteration is completed, and we got our maximum value as 11, and our min value we got was 5. This is our min and max value. Now what we will do, we already know that min we got this index, sorry, I think it is vector is filled, yeah. Min is our this value, maximum is our this value, but for sorting we need the value before min, that is 7, and value before max, that is 10. If we perform sorting from here, just give me a second. If we perform sorting from the index 2 to the index 6, if we sort this, then that is the subarray that is going to give us the answer. So now we will, but we need this array. If we sort this whole array like 5, 7, 9, 11, 10, and if we sort this whole sub array, then we are going to get the fully sorted array. Then our array will become fully sorted. So in order to achieve this, what we will do, we will make a starting pointer which will point on index 0, and it will move from left to right, and it will find any value which is greater than min. It will break. If it will find any value greater than min, it will break over there. So let's see it. So it started from 3. Is 3 greater than our min value? No. Then it will move to 7. Is 7 greater than our min value? Yes. So our starting index will stop at the index 1, which has the value 7. And now as our max is on 11, so for that we will make an end index that will point to the end of the array, that is at index 7, and it will move from right to left, and then it will found if we got any value that is smaller than the maximum value, then it will stop over there. I mean the loop will break. So from right to left, is 20 greater than 11? No. Then iterate. Is 17 greater than 11? No. Next value. Is 10 greater than 11? Yes, 10 is greater than 11. So our pointer E will stop on the index 5, and our answer will be and minus start plus 1. And is 5, minus start is 1, plus 1, so that is 5. And that is the exact subarray length that we have to sort in order to make the whole array sorted. And the time complexity for this algorithm is n log of it's big O of n, and the space complexity, it is not taking any space, so yeah, it just have the time complexity, and the space complexity is O of 1. So let's implement it. Let's code it up. So our first thing is find out the length of this array. And then we have to make the max, and we have to initialize it with integer dot min value, and then we have to make the another pointer min, and we have to initialize it with the maximum value. So for that we need decreasing value. We will iterate from the loop teacher I equals to 1 is less than n I plus plus. If we found any condition where nums of I is less than nums of I minus 1, then we will update our min of I, and for maximum we need to find for the increasing value. Then we will make the for loop teacher I equals to 1. No, it will start from n minus 1 greater than equals to 0 minus minus n minus 2. So if we found any case where our I is greater than the value present at index I plus 1, then we will update our max of I. Now if the array is sorted, then what will happen? Then our max will have the same value as if our min and max value is not changed. That means the array is sorted. Then we will have this check, and if both the array is sorted, then of course the output will be 0. then it will return 0. It will simply return 0. Neitherwise, if it's not sorted, then we need the start pointer that will point to 0 and the end which will point to n minus 1, and we will iterate with start less than n, start plus plus. It will move from left to right and will check if any value which is greater than min present over here, and similarly we'll find where will be our end pointer. So it will start from then 0 and end minus minus. So if anywhere we found our nums of end less than max, then we will break from there and we will return end minus start plus 1. Let's run this code. Yeah, it's working. Let's submit it. Okay, it's done.